Okay, so welcome everybody to Crafting Interpreters in Rust. Uh, we are still in the middle of making this crazy recursive macro thing. Its job is to take a grammar rule in a slightly altered version of the syntax for a grammar rule from the book, and then turn it into Rust code for parsing the structure described by the grammar rule. So for example, this is the first one we tried to do. A class declaration in our target language is made of these things. Um, the the book grammar has some special syntax, like this question mark thing means this whole group is optional, and this star thing means there are any number of functions, um, zero or more. Um, and so the macro has to take those cases into account. So last time we did this case, the optional thing. Um, so um, there are a few more. I sort of have them listed here. This is a version where I added some more patterns to match. So we need this optional group rule. We have that. We need to handle star, so a repeated group. And I think I got that, but I would like to go back and test more. We need a group of options, so separated by a pipe, which means it's one of these three. I'm not quite positive how to do that. Um, the thing I would yeah, we'll come back to that. I think this is the trickiest one. There's something I'm just not sure how to do in there. Like if you have more than one valid pattern that matches, which one do you choose? Like, do you still follow maximum munch?
I would say we can follow the approach as Haskell alternative, and the earliest match wins. That's
Sorry, the
okay.
earliest?
Yeah.
That means the one that takes the fewest tokens?
Uh, well, earliest means leftmost. It's
Leftmost.
not.
Okay,
It's not
so
like we're going to be
yeah.
dealing with arbitrary user input at this point.
Hmm.
The grammar that we're going to parse with this is going to be created by us, so we can always tweak it a little bit.
Okay,
So there
gotcha.
is no ambiguities, and parsing the earlier one works.
So it should be like a while loop, while not
It's not a
matched.
while loop. We check first one, otherwise check next one, otherwise check next one, otherwise we fail.
Okay, yeah, all right. Uh, then okay, so then we had this one already. This is if you just want to match a literal token somewhere. So for example, we have the literal token class and the literal token less for the word class and the less than symbol. Those are all handled by this, where you just want to make sure the token is there, um, or throw an error, uh, and not record anything about the token. Um, there's another case we need to handle, which is we don't want this word function here means you want to recursively call another parsing function. So Michael, would you mind? Uh, you don't want to insert some other blob of code for parsing a function block. You want to call the function for parsing a function block. So we'll generate some other parsing rule for functions, and we need to now have the word function mean go call that function. Go call that. So um, let's see. We go to where what I sort of edited this to. I decided on the syntax. Let's see, where's declaration? Yeah, here's the version with the other patterns added. So these parens, the yellow parens, mean to call another parsing function. And actually, but if we can do it this way, that's probably better because it's more clearly indicates that this is a function. You should go call. And then the outer set of parens with the star means any number of functions. So yeah, this is where we need to get to. All right, so I'll just start sort of reintroducing these things. So here is the recursive function pattern. See, it goes after this case. Okay. So to walk through really quick what it does, you hand it the parsing function name. And I was going to see if I could do that. It calls it. This is the recursive descent part of recursive descent. And that abides by the same function signature as like all the other things we're making, where it returns some structure for what it parsed, and then the leftover tokens after it was done parsing. And then you treat it just like any other. You call recursively on the stuff after it. And if there was an error that came out of calling this recursive function, then you just pass that back up. Yes, that is a GitHub repo. All right. Let's see. It doesn't look like it's good with that. So for some reason, it was okay with me doing this, like surrounding the function name in parens, but it doesn't like that. Is there some syntax I have to use for like literal parentheses?
No, I don't think there is any specific syntax. Path followed by parentheses not allowed by path.
Okay.
Well, yeah, means we cannot do that. We can replace round parents with square brackets with curly braces.
Just to avoid confusion. Yeah, that's fine.
Well, I was thinking using it at the end instead of.
Okay, I'll see if it lets me do that. Seems fine. It's just kind of random.
Yeah.
All right. So let's go ahead and put that in. So left brace, right brace, star, and then we need to actually have the function parsing rule. So I made just, that's less interesting code. That's just making this function struct. So I'll just copy that in. So we have a struct called function. It's based off of how a function is parsed in the grammar here. So identifier, and then an optional list of parameters included in parens, and then the body, which is a block. So I just broke that into the appropriate fields. And then I'm sure we have an impl function somewhere. Yeah. So we need the AST builder function thing. And then the grammar rule. I should probably. is like the book says. They have like a sort of sub rule for parameters, but I just kind of brought that back out. Okay, and then it refers to statement block, which we also need, so kind of like started snowballing. But anyway, this is function. Right, that's the name of the parsing rule that will be generated from this macro call. And what did we just say? Per square brackets?
Yep.
Okay. That means I'll also do the same thing here. Okay.
It's complaining on something.
Yeah. So, I mean, it would be complaining about there's no such thing as statement block. Right. Yeah, it doesn't know what a statement is. So I'm going to have to copy some more stuff over. So
Okay.
a statement is also based off of the book's grammar rule. A statement can be any one of these types of statements. And later we will fill out what the sort of like parts of each one are, kind of like what we had to do for declaration. So a declaration can be any one of these variants, and some of them have associated, data. But for now, a statement is just one of these possible variants. Here's a statement. And then we need, so here's a whole bunch of grammar rule macro calls, right? And I sort of translated the grammar. But let's just take this one. I want to sort of introduce these back in a little bit at a time so that they're not wrong. Okay. So the statement grammar rule is pretty simple. It just means like this at the top level, a statement can go to any one of the following variants. Which is the translation of this. Okay. So something I did, I realized that most of these will have we'll have to supply this build function for how to build the AST. But at the top level, um, there is no such, or like the function would just be the identity. It would just take whatever we get and return it. Because all of the sub expressions also build
I think
statements.
we will have to make them separately. So like one function tries to parse, let's say, first statement, either succeeds or fails. If it succeeds, it uses its own build function and produces concrete type. Otherwise, we try to parse the next one with its own build function and so on.
What do you think? So I kind of thought that any time that we do recursive descent, like for example, we go down to the builder for functions, this itself calls a build function, right?
Yes.
So the pile of data that we'll get going into here will include, functions.
Yep.
So we don't need to, there's a build function at each stage, right? There's not.
Right. This works as expected. I'm talking about those alternatives. Each alternative needs its own build function.
Yeah. So each alternative is going to have its own call to grammar rule. So yeah, they will need their own build function.
Yep.
What
got
I'm
it.
saying is at the top level, this doesn't need its own build function.
Right. At this level, they will be producing the correct type.
Mhm.
So it
Yeah.
would just work.
So all I'm saying is I'm introducing a new variant
Okay.
or a new syntax for the macro at the top level, which is not to supply the function, and then it won't call any sort of build. I was going to say, okay. What did I call it? Yeah. See build function. Okay. So, it doesn't know what this or thing means. And this doesn't know what star means. And this is failing Y as such associated item. Maybe because this one's failing to build. I'm not sure.
Could be.
Yeah. All right. So let's try just putting in these rules. So the next thing we're sort of missing is the star. Here's how I implemented star. So I think what it should do is return a vec of whatever the subtree type is. So this is basically the same thing as the optional, except it does it repeatedly until it gets an error. Let's see. Guess I'll try to write a test. So for the moment, I'm just gonna okay. Comment stuff out until it compiles and then write a test of the individual patterns. Okay. I wish I could. Okay. What's wrong with this piece? Okay. So let's test just the function call part. Um, okay. Do you think Rust is gonna let me expand do the macro expansion here, even though those aren't real symbols?
Yeah, why not? At macro level, it doesn't know anything about symbols or about variables. It just does the dump replacement. So it runs before type checker, before anything.
Okay. It doesn't like the square brackets.
Okay.
Let me just get some infos.
Can I just go back to what it was?
Yeah, let's try that. Shame.
Yeah. Yeah, match bar.
This works. Okay.
That's fine. Let's try that. Let's see. Did I actually put in the rule? No.
Do you want to go into different channel? Yeah, sure.
All right. So for the repeated group,
Okay, I'll just. Okay.
this I sort of copied what we do for the oh shoot. Yeah. I sort of copied what we do for like the first macro we made. Because that the parse binary whatever because that sort of is the same thing.
Mhm.
All right. Go there. All right. So let's see, where's the yeah, okay, so it's matching bar. Does that empty match look reasonable? Okay, I guess it's match this entire block. If it because this is calling the macro recursively. Okay.
Maybe use. It uses parents as it is. Okay. Okay. Yes. Mm,
Okay.
I wonder if we should assign it to some variable and then match that to have more readable code.
Well, you think somebody's going to be reading the expanded code?
Yes, we just did.
Yeah. Okay. Sure. All right. Let subtree.
Recursive or subtree doesn't really matter.
That's fine.
Yep, and it should be more readable now.
Let subtree
Yes.
equals nonsense match subtree. Yeah.
Yeah, I like it more. I think.
All right. They're all recursive, so I expect nesting is fine. Now the optional part also doesn't do that. I can make it do that. I mean the make a variable thing. All right, so where's optional again? So here. Okay. So now we need the list of options part, the OR group. This is the one that I didn't know how to do. So let's see, where did I put it? I put it after repeated. All right. So if we get these, I think I mean we need to call grammar rule recursively on each possibility, right?
What I would try is, so first we need to consider A.
Mm-hmm.
Then if it's success, then we ignore. Then we don't call anything else.
Okay.
Otherwise, we recursively call itself with B and so on. And that will recursively do the right thing, I think.
Interesting. So instead of trying to make imperative code, we just
Yeah, functional programming is
fine. So you make the tokens. That would mean we're not parsing all of them redundantly.
yep.
Yeah. So I mean, you can do the same thing by iterating over this vector until you get one that works. But that means you parsed all of them, even the ones you didn't need to. So,
I think we'll have to parse them anyway because we need to generate the code. But I find it easier to think in terms of recursion rather than imperative algorithms. We can probably try either way. Up to you.
you need to generate the code, but you don't need to actually run the code.
No.
Right? Yeah. This will run the code for each possible thing. Yeah. Okay, so how do we pick it apart? We need
first we need to change how we match it. Right now you capture everything, and we need to capture on a first one separately and then the rest. So it would be A, our first TT, then vertical line.
What should I don't want to just call it first. First
Option, first selection, first variant.
Variant. And then match the rest.
The separator.
Yeah.
And then sub 3, instead of plus, we use star because the same recursive rule will.
Yeah.
Okay.
All right. So so we get the first one, the A.
Yep.
Let subtree equals recursively call the grammar rule on A without the rest. Right?
Yep.
Okay. If it worked, then
it worked and we're all good.
You do what you did for the optional, I think, right? Because you still have to do the tail. So, yeah, call it on the tail. Otherwise, you call it recursively. So you need the subtree, and then we need to repack them in parentheses with the separator. And then
I think the way you wrote it right now will make it generate a recursive code for every tail. We probably want to save the results. If it's okay, then it's okay. If it's not okay, then we do recursive call. And then eventually we either have the subtree or we don't have anything. And at the very end, we do the grammar rule with leftover tokens.
okay.
So we got subtree. We do pattern match. If it's okay, we return that as it is.
Mhm.
If it's not okay, we do a recursive call on the subtree TT.
Yeah, okay, that's what I was trying to do.
But you have grammar rule match leftover tokens tail, line 76. This
So
means it will be expanded on every variant.
wait, but wait. Okay, I'm missing something. I know that I have to do this.
Yes, you have to do this.
I have to put them back with parens around them and with the separator between them.
I mean,
So
you have two tails, right? You have your option tail and then like your expression tail, right?
the tail is everything after this OR group in the grammar rule.
Right. So the way you're trying to write it now, it will be expanding tail for every variant.
Oh, okay.
Does that make sense?
So I see. So we have right. Okay. Yeah, I see. So
at this,
we want to save to a variable, and then at the end
yes,
you return. Yeah.
At this stage, we want either parse the first variant or be recurse in the subtree until we get successfully parsed subtree.
Mm-hmm.
And once we have that, we recurse into leftover tokens and tail.
So I don't want tail on either of these. I
No.
want. So I need to get the tokens out of whatever matches.
Eventually, yes. But first, you want to find a successful parse of subtree,
Mhm.
which can come either from first variant or from also. Maybe we should rename subtree on line 70 into remaining variants or something else.
Sure. Okay. So if we matched,
Yep.
if it's all good, if it's okay, we just return that.
Yes.
And then let
You can call it subtree.
subtree again.
Be fine.
All right. Sneeze. Um, all right. Otherwise, you recurse on the list of remaining variants
Yep.
and not including the tail because we'll include that in whatever result we have here.
Correct.
Okay, so and then here it could still be an error because it might not have matched any of the variants.
Yes.
Um, so here it's this. And then if it's an error, then we return the error from. So I guess this would be
If it's
the last one. I don't know.
Yeah, last one is fine.
Okay. I guess maybe it should eventually be like did not match any of the variants.
Yeah, proper language would probably assemble errors from all of them, but
Mhm.
maybe later.
Cool.
Once we don't have everything in a single file, and once we have some tests in place.
Yeah. All right. So I need to.
You need to specify star.
Yeah.
I think you have too many parents inside. So you need $1 in front of remaining variables binding.
Okay. So this is the.
Then you need to move paren. You need to move vertical line inside of the paren. Things that's way.
Okay.
Okay, let's make a test with, let's say, 2 or 3 simple variants and see how it expands. And we'll need to add vertical line at the end because of, maybe not.
I
Yeah,
thought we already
try
did.
this.
Yeah. I think we already did something like where it's comma delimited, and it was fine with that. But we'll see. All right. Let subtree equals try to get bar.
Yep.
If it's okay, subtree,
It's not okay, try pass. Awesome.
but try best. I put 3 variants in.
Yeah, that's so this ends up matched by something else. I think we have a rule where we have just the parents.
I think so. I see what's going on. Yeah.
So maybe we need the vertical line at the end after all and somehow handle it in current rule, or we try to do the right thing in some other rule.
Let me change. I'm just going to change the parens to square brackets here. Not try to put them at the end, but just have them be square brackets.
Okay.
Then it won't be ambiguous. Then if we just have one set of parens, hopefully it'll just not matter. I hope.
It's
Let's see.
I think it gave up expanding.
Okay, because it didn't match anything.
We don't have any rules, yes.
Okay. Well, in that case, doesn't that mean Does that mean we need, let's see, one of these sort of base case rules?
Yeah.
What's wrong?
So we can try making this base case more explicit. So at the moment, everything is prefixed with manch. We can make alternative parser to be prefixed with something else.
Mm-hmm.
Let's
Okay.
say alt.
Yeah. Okay, so we like here.
Yes. But in this case, no, is it that's not alternative? It's optional group.
Oh, my bad. Yeah. So in OR group, when we do this.
Yeah. So for that, we'll need to change the base case a little bit. So the point of the base case is going to be detect something separated by the vertical lines, call recursively on something that handles those vertical lines specifically, and then proceed with the rest.
Okay.
It should, so if you copy everything from the body down here,
I'm lost.
um,
There's...
you don't have to have it at the end. Having them side by side would make it a bit easier, I think.
Sure. So if we're parsing an OR group,
Yes, so instead of first variant and remaining variants, we just capture all the variants separated by vertical lines into variants.
Mhm.
If you think so, go to line 70. Copy this pattern match, all of it, and move it into the OR group, including first variant.
Oh, like this?
Yeah.
Okay.
This will contain lines 71 to 80. So move those lines there.
And then are we going to replace this with the call?
Yes.
Okay. And then this is going to just be all the variants.
Yeah.
That look right? Oh, I need the print. Okay. Are we... Okay, so this is that.
You probably need to reintroduce tokens variable. That is on line 85 up there. And here we need to add the base case for our group.
And we still need this.
Yes, we still need this.
That's the same, right?
I don't think it's the same. We need to run the parser. It's the same as with the first variant. It's just it should not recurse to the remaining variants. Like, is it line H7? And that would be it. So just line 87.
That means I need to parse the fact that it's one variant, right?
You need to match first variant.
Yeah.
Uh,
In literal parens.
literal parents, vertical line at the end if we include it or not if we don't include it.
I'd rather not.
And we need to include literal parents when we're doing the recursive call. That would be line 93. Yeah, so parents around all of this outside of the dollar sign, and yes. Sub3, don't think we need to assign this let sub3 at line 98 to a variable. We can just return it. Yes. Okay, let's see how it expands.
Let me make sure. Is it okay to have a semicolon here, or do I need to assign this to a variable?
Yeah, you need to assign it to sub3.
All right. So this is parse the OR group,
Yep.
and then it will give me the first one. Then I attach the tail.
Successful.
All right. So it doesn't like something.
No rules expecting this target in the macro call. Our group tokens. We lost parents on line 72. They should be parents around the variants.
Okay.
Maybe we can drop them in the recursive variant, a recursive call. Okay, let's see how it works.
Still doesn't like it. Let's see. Is this this should be the same as that.
Yep. So it doesn't like
Same thing.
parentheses. What parentheses have you passing?
Oh, these cases need semicolons.
Yes,
I
they
just
do.
forgot them. All right.
Okay.
All right. So let's go. That doesn't look right.
That doesn't look right. Uh,
So it didn't even match this.
no such associated item. Okay, let's try. So when I debug macros, you can add some random variable assignments.
Yeah.
For example, if yeah,
So yeah, I don't think it's matching it at all. It's somehow we put or group on the right ones, right?
yeah, but it doesn't even match much.
Yeah.
So it should have parents. Let's go back to the line 90 something. So I think go up a bit. I think we messed up something around line 70. So there are those parents. We lost $1 sign. We need $sign in front of the second parent, not the first one.
Here.
Yes, this $sign makes star special.
Okay. That makes sense. So this is matching. This is what to call each variable inside the pattern.
Yeah.
Okay. Gotcha. All right.
That's a bit better. We matched.
Might be a similar thing.
Well, I see both. We don't really need those parents in recursive call
Okay.
on line 73, so we can try to get rid of them.
So this will just make literal parent, or this will not make literal parens. It will just separate the variance by or.
Yeah.
Okay.
And we need to update line 86. Yes, and line 98. There is no parents there either. And if you add like x equals 6 or something at line 87, for example,
Is
to see if it matches. Vertical line should go between paren and star.
okay.
Because that's the separator syntax. And I think
Yeah. Okay.
it changed its mind about something.
All right. Or. All right.
Get in there. I see bar, I don't see anything else.
Yeah.
So first round matches, the rest is not.
Is this
Because we still have parents on line 94 that we just removed. And vertical lines should go between.
Same thing. All right.
Okay, that's
Bar.
bus. No, yes. It's doing something with bus
As quirks.
fix.
Does the overall structure of this look okay? I can't tell. I think it's we don't want this, do we? We want that.
Yeah. Okay. So 3. Well, I think we're getting somewhere. Like it tries all the variants.
Try bar. Try Baz. Why is the structure, the nested structure, not the same on each level? Maybe it is.
Recursively nested because first we try one. If it succeeds, we produce it. If it not, we try the second one.
Mhm.
And each variant adds extra nesting. That's expected.
All right, so each one has a let subtree.
Yep.
Try the first variant. Otherwise, and then match. Otherwise, nested. Okay.
Yep.
Makes sense. Okay. So I think this is right.
Yep. I wonder if we managed to crash this Rust C compiler by the end by creating some horrible abomination.
I hope so. Okay. So let's see if we can bring back the real rules.
I don't think we can.
No, because of all of these.
Don't have them.
And we need to make them square brackets. Okay. Now, is there anything else from this that I didn't copy over? I think we're eventually going to need a variant for each type of token that has data inside it, right? Like a number. Yeah.
That should be a problem.
Okay. Nice. All right.
I think
Well,
it's a good wrap-up point. It's 8.
yeah. I'm happy with that. Is there anybody else left? Yeah, there's lots of people actually. Does anybody have questions about what the hell we just did?
That was pretty cool. I hadn't really, I was just kind of reading the macro documentation as you guys are doing this. But it looks like Munch is this macro library that lets you find these DSLs. I was kind of looking at some of the examples, and but I guess you guys are definitely taking a very different approach to this class. It's kind of neat.
Well, original book suggested doing some stupid pretty printing to generate the code. Since we're using superior language, we decided to go with the most difficult way.
Yeah.
And there is no good information on how to use macros. So I'm trying to explain stuff we're doing as we go. Maybe once we're done, there will be some information and somebody will be able to follow us.
Oh, there's a link book for macros.
I've seen that.
Thank you, whoever starts.
All right. Well, let's see. So next time, I think this macro is done except for the sort of primitive variants. So we need number and string.
That's lexical.
Oops.
We already parsed it somewhere, I think.
Yeah, the Lexa already did it, but we need to actually pull out the information.
Okay, we can do that.
And then the macro's done, and then we can like actually start making all the enum types and translate these rules, and it'll be great. All right. Cool.
Sounds
yeah.
good.
Thanks, guys. I will stop recording.